And if I told you once, I ain't gonna tell you twice. Or maybe I will tell you twice. I ain't gonna tell you twice. Salute all my real ones. Salute all my real. Salute all my real ones. Yeah, look, bro, we got a star that's 200 million years older than the universe. Cap. I'm calling Cap. I'm calling Cap. Unless that star was from a different universe, because there is a theory that there are multiple universes that live parallel to each other, but they never touch or they never interact with each other. Unless that star is from a different universe and they just happen to cross over into our universe, I'm calling Cap. How can a star exist before the universe? But, you know, we gonna watch the video. You know what I'm saying? I don't know it all. And I don't claim to know it all. And I never went to Harvard or Yale. I'm not the smartest person in the world. I know that. But 2 + 2 = 17. So, before we get into this video, like button, subscribe button, notification bell, press those. Let's go.
Meet HD 140283, or Methuselah, the oldest star in the universe. It's 14.5 billion years old, a number that's difficult to get your head around. After all, our universe is only 13.8 billion years old. How is this even possible? How can anything have appeared earlier than space, time, and the whole universe? Scientists have been observing Methuselah for the past 100 years. Until recently, very little was known about this star, only that it's located 190 light-years from Earth in the constellation Libra and penetrates outer space at a speed of 800,000 miles, or 1.3 million kilometers per hour. This was pretty much the sum of our knowledge about Methuselah, and the star itself did not cause keen interest for many people. However, everything changed dramatically when, in 2000, astronomers attempted to measure the age of Methuselah. According to early estimates, it was a record 16 billion years old. Scientists could not believe that this was at all possible, so they decided to conduct further research. Howard Bond of Pennsylvania State University, along with his colleagues, collected more than 11 sets of observations that were obtained between 2003 and 2011 using Hubble's fine guiding sensors that record the positions, distances, and energy of stars. In addition to this, for 6 months, Bond studied the parallax effect, that is, the change in the apparent position of a star relative to the distant background, in reference to the position of the observer. This allows you to better calculate the ratio between the brightness of the star and its distance from the Earth, since the older the star, the dimmer its light will be. During this study, Bond could not justify the earlier estimated age of the star, so he supposed that mistakes were made in the previous calculations. Initially, the age of the star was measured by the rate of nuclear reactions. The faster the star consumes hydrogen in the core, the younger it is. With age, instead of hydrogen, helium is formed, acting as stellar fuel. Therefore, after 1 billion years, a star loses some of its brightness. Methuselah is rather dull and estimated to have burned hydrogen for about 16 billion years. True, this method of calculating the age of a star cannot be considered accurate. This led scientists to look for other clues that could prove that Methuselah might be younger. After some time, scientists still found one sign that most likely indicates a younger age for the star. It has to do with oxygen.
Dog, so far, I'm not hearing nothing that'll make me say, yo, a star is older than the goddamn universe. Because then, what did it exist in? What, there's no space. And how, if there's no universe, there was no Big Bang. And there was infinite mass in the Big Bang. And that's where all the matter for the universe came from. If the star existed before that, where did it get its mass from? Unless there was a Big Bang before the Big Bang. Pause.
In the early universe, it was practically non-existent, but in Methuselah, the ratio of oxygen to other elements was quite high. The increased oxygen content, together with all the other indicators, allowed scientists to lower the estimate of the present age of the star to 14.46 billion years. But this still doesn't explain the phenomenon, because this makes the star 660 million years older than the universe. But researchers didn't stop there. They continued to try to get to the bottom of this mystery. In 2014, another study was conducted that reduced the estimated age of the star even further to 14.27 billion years. Given the margin of error in the calculations, the star is about 14 billion years old, which still makes it 200 million years older than the universe. However, Howard Bond considered that the error could be greater, which means that the star is perhaps younger and appeared immediately after the Big Bang. This could have been the end. But there's another study that simply shocked astronomers and perplexed the entire world. According to information obtained in 2013 by the Planck Space Telescope, the universe can only be 11.4 billion years old, not 13.8. Similar conclusions have been based on the expansion rate of the universe. Until the end of the 20th century, physicists believed that the universe was expanding at a rate of 41.63 miles or 67.4 kilometers per second. Given this indicator, scientists obtained an age of 13.8 billion years. But according to a newer study, the speed is approximately 45.9 miles or 74 kilometers per second. According to these...
But wait, the expansion of the universe isn't constant. It's been accelerating, so at a certain point, it probably was slower.
Numbers, the universe is only 12.7 billion years old. Then, scientists made even more accurate calculations, and it turned out that the universe is expanding even faster at 50.95 miles or 82.4 kilometers per second, which means it's only 11.4 billion years old. The expansion rate of the universe, the so-called Hubble constant, can be calculated in two main ways: by studying the relic radiation and by measuring the distances between galaxies. In the first case, the Big Bang itself provides basic information. After this grandiose event, which gave rise to everything, light was left behind, which scientists call the cosmic microwave background, or relic radiation. Astronomers have compiled extremely accurate maps of this background, which allows us to simulate the early universe, its composition, and speed of expansion. By the second method, astronomers collect data from galaxies, stars, and supernovae. These objects change their luminosity as they move further away, so that you can measure the speed of the expansion of space. This is where all the inconsistencies begin. According to the first method, the age of the universe corresponds to the number that you'll see if you search on Google or Wikipedia. That is 13.8 billion. However, in terms of the second method, space and time are a couple
I highly suggest that you don't rely on Wiki for all your information. I'm just saying.
billion years younger. Perhaps our universe, during different periods of its existence, simply expanded at different rates of speed. Only none of the existing theories today are able to explain this. The fact is that the expansion is influenced by dark energy, the opposite force to gravity. True, no one knows for sure what this mysterious force actually is, but physicists were always sure that it was constant. But if this were so, the rate of expansion would also remain stable throughout the entire existence of the universe, which is not what we observe. So, it would seem as if we have missed something. There's probably something that can influence dark energy. Physicist Massimo Cerdonio from the University of Padova tried to figure out what exactly causes our universe to be so unstable. He's focused on the fact that dark energy is largely dependent on quantum fields. Each similar field is assigned a separate type of particle and extends to all of space-time. For example, all electrons belong to the field of electrons, and neutrinos, respectively, to the field of neutrinos. The energy arising from the interactions of these fields determines the expansion rate of the universe. However, when physicists try to calculate the energy of all existing quantum fields, the result is a number 120 orders of magnitude greater than the calculated amount of dark energy. Therefore, Massimo Cerdonio suggested that there must be a special particle, unknown to science, capable of influencing dark energy and the entire universe as a whole. True, the presence of such a particle has been predicted in earlier research in the field of physics and has even been given a name, axion. Presumably, this particle appeared immediately after the Big Bang, but has remained hidden for billions of years and did not manifest itself in any way. But recently, the axion has gained influence and has changed the entire field of research about the development of the universe with its quantum field, thanks to which we can no longer accurately say when space and time itself arose. This leads to curious thoughts. If the universe is expanding faster than it did 13 billion years ago, does this mean that time is also passing at a different speed today? That is, would 10 minutes in the 21st century be different from 10 minutes at the dawn of the universe? It's rather difficult to answer these questions without ambiguity. But whatever the answer, Methuselah still remains older than the universe. At least, it will be so until scientists solve the mystery of dark energy and its elusive particles.
This is YouTube playing them games. So the star is not actually older than the universe. It's just, as far as we know, we can't get the age of the universe correct, and we can't definitively say the age of the star. Got it.
True, if after all future calculations, this star remains the oldest in the universe, maybe then there was something else before the Big Bang. What do you think about it? Share your opinion.
But yeah, man. So let me know in the comment section what y'all feel. Do y'all feel that it's possible for a star to exist before the universe? I'm of the mindset that no, but I could be wrong, and who am I? Do y'all think that the universe is accelerating faster than it was when the Big Bang first happened, or not? Let me know in the comment section. I would love to have that discussion with whoever wants to talk about it. My name is Rain. Catch you on the flip side. RCP salutes. Wait for it. Dab on them.